Hello Math 1. This video is on 9.f, which is I can graph a system of linear inequalities. Now, if you're pretty good at graphing linear inequalities, a system of linear inequalities is not that much more difficult. So first, what is a system of linear inequalities? It's basically at least two linear inequalities in the same variables, okay? Generally, the variables are x and y. Right, but they could always be something different. Okay, and a solution to a system of linear inequalities is an ordered pair that makes all, and that's the key part there, all of the inequalities true. So if we were to take a look at the first example here, determine if the ordered pairs are solutions to the system of linear inequalities. Well, what I'm going to do is basically take these ordered pairs, take the x-coordinate and the y-coordinate, substitute it into each of these. If it makes one inequality false, it is not a solution, right? If it makes all of the inequalities true, it is a solution. So the first one, if I plug 0 in for x, is 0 greater than or equal to 0. That checks off. Okay, is 0 greater than or equal to 0. That checks off, right? Now this one here, negative 4 times 0 plus 3 times 0, is that going to be less than 12? You know this is going to give you 0. Is 0 less than 12? That checks off. How about the last one? Is 0 less than negative 2 times 0 plus 8? Is 0 less than 8? That checks off. This ordered pair makes all four inequalities true. Therefore, it is a solution. How about the next one? If x is 6 greater than or equal to 0? That checks off. If I replace y with 5, because that's x, that's y, is 5 greater than or equal to 0? That checks off. Is negative 4 times 6 plus 3 times 5 going to be less than 12? Is negative 24 plus 15 less than 12? I would say negative 9 is less than 12. That checks off. How about the last one? Is 5, I'm replacing y with 5. Is that less than negative 2 times 6 plus 8? Is 5 less than negative 4? That is false. Therefore, that is not a solution. So what I'm basically doing is plugging each of these ordered pairs in all four of these inequalities. So look at the next one. Here's x, right? Is negative 2 greater than or equal to 0? That there is false, so right away, that's not a solution. The next one, if x is 1 and y is 3, is 1 greater than or equal to 0? Good. Is 3 greater than or equal to 0? Good. Now, is negative 4 times 1 plus 3 times 3 going to be less than 12? Is negative 4 plus 9 less than 12? You should see 5 is less than 12. That checks off. And then the last one is 3 less than negative 2 times 1 plus 8. Is 3 less than 6? That checks off. 1, 3 is a solution. Letter E. Check it up. Is 3 greater than or equal to 0? We're good. Is 2 greater than or equal to 0? That's good. Is negative 4 times 3 plus 3 times 2 going to be less than 12? Is negative 12 plus 6 less than 12? That checks off, right? Because negative 6 is less than 12. Then, is 2 less than negative 2 times 3 plus 8? Is 2 less than 2? That is true. Therefore, that is a solution. And the last one, is 1 greater than or equal to 0? Good. Is 1 greater than or equal to 0? Good. Is negative 4 times 1 plus 3 times 1 going to be less than 12? Is negative 4 plus 3 less than 12? Good. Is 1 less than negative 2 times 1 plus 8? Is 1 less than 6? That works out. Therefore, 1, 1 is a solution. Okay? So now, when we graph a system of linear inequalities, the first thing we do is we graph each inequality. Okay? We're going to graph each inequality in the system. And with this, it benefits to shade, right, each inequality very lightly and to use different colors. Then we're going to identify the feasible region. And remember, the feasible region is basically the intersection of the shaded regions where all of the solutions exist. Okay? So we're going to identify the feasible region by highlighting the intersection of all the shaded regions. So we're going to start with an easy example first. Okay? So what we're going to do is we're going to come up here. All of the boundary lines for these inequalities have been graphed. All you're going to do is the shading. Okay? So I'm going to start with the first one. X is greater than or equal to 0. That is this line here. Okay? This inequality is this line here. Now, x greater than or equal to 0. If I look at that, I should know that if that vertical line is my boundary line, and I use 0, 0 as a test point, even though that goes through 0, let me use 1, 0 as a test point. Is 1 greater than or equal to 0? Yes. Therefore, I know I'm going to shade to the right of that line. And I'm going to go ahead and shade all of the solutions. Right? I'm going to shade all of this in. Okay? Now, I'm fortunate enough to have colors. The next one, y is greater than or equal to 0. The boundary line is right here. Now, I'm going to choose a test point of, say, 0, 4, which is right here. Is 4 greater than or equal to 0? Yes. Therefore, that tells us we're going to shade above the line because that's inside the shaded region, or inside the shaded region. So right now we're sitting in the first quadrant for the intersection of the two graphs. So we know quadrant 2 and quadrant 4 will host no solutions, and even 3. Okay, so now we move on to the next one. If I look at this one here, the boundary line there is this one right here. That's the boundary line there. Now, if I use 0, 0 there as my test point, is 0 less than or equal to negative 3/5 times 0 plus 6? Is 0 less than or equal to 6? Yes. Therefore, when I go to shade this, I know I'm going to shade below it towards 0, 0, which is all right here. Okay? Now, the last boundary line, right, we know is this one right here. And if I look at 0, 0 there, is 0 less than or equal to? Just know that negative 4/3 times 0 is 0, 0 plus 8 is 0, or 8. 0 is less than 8, so we know we're going to shade this way. Now, I have a lot of shaded regions going on, so what I'm going to do is kind of erase all this. So I know right away that all of my graphs the intersection of all the shaded regions were in here to begin with, right? They were in here to begin with. But then, when we graph the shaded region for this line, right, we shaded all of this in. But now we have the shaded region for the other one, right, where we said 0, 0 is a solution. So we're going to shade all of this. Now the key is, where do you see the yellow, the blue? They intersect over in here. And then how about this gray region now, right? All of those shaded regions are inside this here. This here is your feasible region, okay? That is the intersection of all 4 inequalities. So let's take a look at an example. We know graphing this inequality here, the slope is 1/3 and the y-intercept is 0, 4. So 0, 4, I'm going to go up 1 over 3. The inequality tells me it's going to be dotted, right? So I'm going to draw my dotted line. Now, 0, 0. Is 0 less than 1/3 times 0 plus 4? Yes. Therefore, 0, 0 is in the shaded region. Okay, so this is a shaded region for that. Now the next line, right? Y is greater than or equal to, or greater than negative 2x plus 3. Slope is negative 2, right? The y-intercept is 0, 3. So I go to 0, 3. I'm going to go down to right 1, down to right 1. Again, that's a dotted line. So there's a boundary line there. Now, does 0, 0 make that true? Is 0 greater than negative 2 times 0 plus 3? Well, 0, 0 makes a false statement here. So that tells me I'm going to shade the opposite way. 0, 0 would not be shaded. So I would shade this side of that blue boundary line. Where do you see, right? Where do you see the yellow and the blue intersect? The feasible region is this area right here. That's where the shaded regions intersect. Okay? And the last one. X greater than or equal to 0. So this boundary line is probably the easiest to graph. X greater than or equal to 0. I know I'm going to draw that vertical line, and I'm just going to lightly shade this way, right? Then I know y greater than or equal to 0. That is the line right here. And greater than or equal to 0, I'm shading above it. Okay? So right now, all of my solutions exist over in this first quadrant again, right? But I have these to go by now. Here, I'm going to graph these using the x and y intercepts. My x-intercept, I'm going to let y equal 0. If I divide 36 by 9, I'm going to get 4. So I'm going to plot 4, 0. 36 divided by negative 12, if x is 0. 36 divided by negative 12 is negative 3. So we're right here. I know that's going to be a dotted line, like such. And if I plug 0, 0 in, is 0 minus 0 going to be less than 36? Yes. Therefore, I know I'm going to shade above this line. So right now, if you think about it, the region I'm focusing heavy on is from here. It's this region here. And I still have one more line to go. So if I graph this last line, slope, negative 7/4. Y-intercept, 0, 7. 0, 7. I'm going to go down 7, right 4. That's right here. I know it's going to be a solid line. And if I plug 0, 0 in, is 0 less than or equal to negative 7 fourths times 0 plus 7? Is 0 less than or equal to 7? Yes. So if 0, 0 is that there, I know I'm going to shade on this side of the line. And where does my feasible region end up being? Ends up being this section right in here. Okay, it's that triangle there. I'm above y greater than or equal to 0, to the right of x greater than or equal to 0, and all the other shaded regions. Hopefully this makes sense. Let us know if you have questions.